Today our show is about cycles. Cycles are recurring patterns, like when you stop your bike at a traffic light. It's time so the lights go green, yellow, and red, and they keep cycling minute after minute, hour after hour, day after day. And it's like the wheels of a bicycle that spin round and round and, well, this isn't really a bicycle. This is a gnarly cycle. I'm going to give it a try and see if I can find TJ. See you later.
There are all kinds of cycles that affect our lives. Time is measured in cycles. Every 24 hours, you start a new day. Clocks tell us where in the cycle we are. Clocks have their own internal cycles to keep time. A grandfather clock uses a pendulum swinging back and forth to control the gears. A clock is a short cycle compared to the Earth rotating around the sun every 365 days to make a year. Now, in case you're wondering why I'm wearing this trash bag, it's the latest in outdoor fashion. It looks great, doesn't it? Just kidding. Actually, Ed and I have been collecting trash that we accumulated for the short cycle of a few days, so we can talk a little later about the trash cycle. Now, are you ready for question number 1? Here it is. What kind of cycles can you name?
Cephas, it took 1 week for this show to cycle.
That's right, Clyde.
I bet the students missed me.
A letter came to me from a fin fan. Did you get any, Clyde?
No. Humans.
What is all this stuff, Ed?
TJ, I'm using this to look at sounds.
He's looking at sound?
Since we're talking about cycles, I thought I'd demonstrate how sound travels in cycles. Everything we say and hear goes in cycles. In fact, while I'm talking, you can see the pattern of my voice on this oscilloscope.
I sure can.
TJ, why don't you whistle a nice steady tone here?
Okay.
That's great. You could see the volume of the sound and the height of the signal, and you could tell the frequency or the wavelength by how close together the waves were. Now, try one this time that's a little bit higher pitch. Wow.
Well, you can really see a difference there.
That one had more volume, it was taller, and it was a little bit closer together.
So like the lower the pitch of the sound, the slower the cycle?
That's right. That's
okay.
right. We've got an omnichord here, and unlike the whistle where you had a steady tone, the omnichord will produce several different tones. So let's give that a try. Wow, you can see lots of different cycles in there.
Sure can.
Try a different one.
I'll try this one.
Looks pretty much the same, about the same volume, but a lot of things are going on in there, aren't there?
There are.
When we make sounds, like with the omnichord or when you whistle, the sounds are composed of different frequencies. And that's very important because we all hear different frequencies differently. So you can hear much higher frequencies than I can hear. In fact, over here we have an oscillator, and the oscillator will produce sounds at different frequencies, and we can try out and see how your hearing is. In fact, everybody out in the classroom will see how your hearing is also. I'm going to turn on the oscillator at 300 cycles a second.
300? That's a lot.
It is a lot, but that's 300 times each second the air molecules that you hear are moving back and forth all the way into your ear.
I see.
Now, I'm going to crank that up 10 times to 3,000 cycles.
3,000?
3,000. You can
Wow.
still hear it very well, can't you?
Yeah, I can.
So that's oscillating very quickly at this point. Well, let's keep on going, and TJ, you tell me when you can't hear it anymore, and everybody out there in the classroom, you see how high you can still hear this signal. There's 4,000, 5, 6.
I can still hear it.
Yep. There's 10,000 cycles a second, or 10,000 movements each second. Now I'm going to turn up the volume a little bit.
Well, I can still hear it.
Boy, I can just barely hear it. I can't hear it at all at this point. Can you still hear it?
I can still hear it. I can't hear it anymore.
You can't hear it. That's about, looks about 17 and a half or 18,000 cycles a second. I'm going to take it on up, and you see in the classroom if you can hear it any higher. I'll crank the volume way up.
I wonder how they did.
Yeah, I wonder how they did. Well, you know, humans can hear up to about 20,000 cycles per second, but as we get older, our hearing decreases. So in my case, I could only hear up to about 13 or 14,000 cycles a second. Now, other animals, for example, bats can hear very high frequencies. In fact, They use their sonar to catch insects and to find their way in caves.
Hey, Cephas, do I look gnarly to you?
Hey, man, I don't know. What does gnarly mean?
It must mean sophisticated, good-looking, and most cool.
No, man. You most definitely do not look gnarly.
TJ, here we are in a greenhouse on a glorious sunny day. What a great place to be today, and a great place to talk about cycles. Because in a greenhouse there are so many different kinds of cycles we can talk about. First off, it's daylight, and the sunlight is coming in through the glass roof, and it's warming up the entire building. And of course, the plants need sunlight to make food, but it's also warming everything up. Now tonight, when the sunlight goes away with the day and night cycle, the sunlight goes away, the building and the plants will be re-radiating that energy back up, but it won't be able to get through the glass roof because only some kinds of light can get through the glass. So we've got a day-night cycle that is so important in a greenhouse. We also have a water cycle that's important because this plant and all the other plants in the greenhouse need lots of water to grow. And in the greenhouse, they give it water through a little irrigation device like this that drips water into the soil, and the roots of the plant absorb that water, and eventually the leaves give that water back up to the atmosphere. So we're recycling all the water.
Not only do cycles naturally occur, but they can be affected by outside forces. We can affect our respiratory cycle by smoking cigarettes.
That's right, TJ. Let's do an activity that shows how smoking tobacco affects our lungs.
All right.
We've got a bottle here that will represent our lungs, and if you would jam a cotton ball into it, the cotton ball will represent the inside of our lungs, all the little tiny air passages in there that we depend on to breathe. And now let's put a cigarette on the outside, and we'll hold it in place with some modeling clay. You could try this yourselves, but make sure there's a teacher or a parent with you if you do, because we're using matches and cigarettes, and these are things you have to be especially careful with. Okay, I'm going to light the cigarette, I think. We'll try it again. And TJ, once we've got it lit here, if you would go ahead and smoke by pushing the bottle in and out.
Because this is like our lung.
That's right. So we're drawing some of that smoke into our artificial lung. I'm going to put a bottle on the outside just to capture the smoke, just so you can see the amount of smoke that's generated from one cigarette. You know, we breathe about 15, maybe 20,000 times a day, and we're just taking a few puffs here with one cigarette, and we'll see what effect that has both on the inside of our lungs and on the air around us. You know, when you smoke a cigarette or when a cigarette burns, it generates some gases, and we can't see the gases, but some of those are poisonous. Some of them can really hurt us. And it also generates a lot of smoke, and the smoke you can see. All it really is lots of particles that are floating through the air. TJ, you're going right through that thing, aren't you? You're going to be done in just a second.
A few more puffs here.
All right. We have lots and lots of smoke in here. Think that's enough?
I think so.
Whoa, look at all the smoke that was generated into the air around us. Even if you don't smoke, if you're around somebody who smokes, you're going to get a lot of that in your lungs.
It's disgusting.
Now we're going to take this off. The cigarette is still going. And see if we can get the cotton ball back out. Okay, there we go. After just one cigarette, you can see there's a fair amount of color on this cotton ball from all the tar or the smoke particles that were collected on the inside. You can see the one that was in the bottle versus the one that was not in there. So smoking is a pretty dangerous activity. We get all these materials into our lungs, and that can decrease the lungs' ability to fight diseases such as emphysema and influenza, the flu, and even things like cancer and bronchitis.
Well, now that we're learning how cycles can affect our lives, we can make better decisions about what we do, like deciding that we don't want our lungs to go up in smoke.
That's right, TJ. The smoking cycle is downright unhealthy, but there are some cycles that we can affect that are good for us. I'm back at the Wise greenhouse, and we're seeing how people can affect the cycles, and specifically in the greenhouse, how you can affect the cycles for plants. Brenda, you're giving these plants some water. You're changing their water cycle.
Right, Ed. We can do this individually with the hose, or we can turn on the beds individually and water each pot.
Most outdoor farmers, most outdoor growers don't have that luxury. They can't turn the water on and off. They have to depend on the rain. But here in the greenhouse, Brenda is able to change the water cycle by flipping a switch and giving the plants a drink. It's also interesting, Brenda, because you give the plants nutrients through your water system.
Right, it's pumped out with an injector directly through the hose and the water lines.
So that's very good control of that nutrient cycle, because you know the nutrients won't wash away like they might outside. You give it to the plants directly with the water. There are other ways we can control the cycles here in the greenhouse, Brenda.
Mm-hmm.
Brenda, what are you doing now?
I'm adjusting the temperature with the thermostats.
So you can affect the heat cycle here in the greenhouse.
Right, Ed.
I guess you have to turn the heaters on because you don't get enough heat through the ceiling from the sunlight.
Right, Ed.
Brenda, sometimes you probably get too much heat and moisture in here. And how do you get rid of that?
We have exhaust fans on each side of the greenhouse that we can adjust with the thermostat.
So you turn that on, and it draws out the warm, moist air.
Yes, Ed.
Well, you've been affecting the cycles very well. You see all these beautiful green, lush plants here. You can control the cycle so closely here. Brenda, thanks very much for showing us everything here in the greenhouse.
Okay, Ed.
Farmers outdoors can't control the cycles the same way that they can inside at the greenhouse. Question number 2 for you 4th and 5th grade students is, how can farmers affect the cycles of their crops?
Ed and I have been collecting trash for a couple of days. This one's mine, and this one's Ed's. You can see that Ed's a little more trashy than me. If we didn't recycle, that'd be a lot of stuff to throw away. A lot of people think when garbage gets picked up at their house on trash day, it just disappears. Not really.
TJ, we've been sorting through our trash at the studio. Here we are at the landfill. This is where it all ends up.
Right.
Ken, there's some activity going on behind us. What's happening here at the landfill?
Well, behind us is where the trucks come into the landfill, and this is where they're dumping today. There's a large piece of equipment back there called a landfill compactor, and the job of the landfill compactor is to spread the trash and then to roll over it several times using the special cleated wheels that are on the machine to break up the trash and compact it to the smallest possible volume.
Now, when the trucks come in, they go over to the edge here, the big abyss or the hole behind us, and they just dump it in that hole. Is that right?
Well, that's not exactly right. What you can't see over behind the equipment is a sloping working face where the trash is dumped, and we maintain that slope so that the compactor can roll up and down it and compact the trash.
This is an enormous hole, but at some point it's going to be all filled up with our refuse. How long will it be before it's all filled up?
Well, at our last estimate, we expect the landfill to have about 9 more years of life, although we're working with our consultant to see if we can't get permission from Ohio EPA to expand the landfill and create some additional years of capacity.
So after the 9 years, do you just make another landfill, or you just go to a different location?
We won't be able to use this location anymore, and yes, we'll have to go to a different location, either create a new landfill or try to use an existing landfill at another place.
When we visited the landfill, we learned that garbage is pretty much at a dead end. I mean, it takes years and years and years for the materials to recycle themselves.
But here at the Akron Recycle Energy System, garbage is recycled very quickly. Garbage trucks dump their garbage into the giant pit behind us, and from there, metals are extracted, and those can be recycled. The remaining materials are burned to generate steam. Kelly, how is the steam used?
Primarily as a heating source for the buildings downtown Akron.
So instead of using new materials of oil and gas and electricity, we can use old materials like garbage to provide heating.
It's a form of recycling, yes.
This is a great way to recycle garbage, turning it into a useful product like energy.
Maybe the students can think of other ways to recycle garbage.
I hope so.
You know, sometimes man and nature together can affect a cycle.
That's right, TJ, and we can demonstrate that right here. We've got 2 different boards, and we're going to let each board represent a hillside. Yours can represent a hillside that has some plant material on it. We won't have any real live plants, but we'll have plenty of material mixed in with the soil, some leaves and some grasses. And on this hillside, I'm going to have just soil, as if all the plants had been removed. TJ, you want to get one more handful of the leaves and mix it in there. And meanwhile, I'll start to put some soil on this one. In this activity, we're really representing 2 different cycles. The first is the water or rain cycle, because we're going to have rain coming and hitting the hill. The rain, of course, has come from the ocean. It's been evaporated up to the clouds and will come over our hills and rain, roll back down into streams and out into the ocean. How you coming there, TJ?
Good.
The second cycle is the cycle of mountain building and erosion. We're not going to show the mountain building. We're just showing the erosions. Like everything else, mountains grow up and they decline. And declining is erosion, and that's what we're going to show here. Pat that down real well, and I'm going to pat this down. Maybe just a little bit more, and then the rains can come. Okay, so you've got lots of rich organic material over here, and I don't have any.
Is that enough?
I think that should do it.
Okay. Let's put a little more.
All right. And now we're ready for the rain. And what do you think is going to happen when we rain on both hillsides? Can you see that one's going to have a different effect? Let's give it a try, TJ. Ready with the rain.
Well, look, yours go.
My hill has eroded away very, very quickly.
Mine hasn't done anything.
That's right. You can see that there's a little bit of soil leaving, but in general, the hillside is still there. My whole hillside has eroded down into the stream and is gone. There's one way we affect a cycle, because when we come in and cut the trees and the bushes and all the plants, there's nothing left to hold the soil there. So the rains come and erode the hillside away, filling our streams with soil and losing that soil.
Right. This activity should help the students with question number 3, the biggie. How does cutting down the rainforest affect us?
TJ, this is wonderful. We're right here in the middle of a rainforest at the Cleveland Metro Park Zoo.
Yes.
Rainforests are neat for a lot of reasons, one of which is they make their own weather. The rains fall on the forest floor, and it gets very quickly evaporated up to the clouds, and it rains again. So we have a lot of recycling of that water. And in that environment that's warm and moist, it's a great place for plants to grow.
Right. I mean, almost 50% of our oxygen comes from the rainforest. So we here in Ohio need these rainforests, even though they're thousands and thousands of miles away.
That photosynthesis that we talked about occurs in rainforests, and as you say, lots of the oxygen that we need in Ohio comes from these rainforests. And with all those plants growing throughout the rainforest, it's a great environment for animals as well.
Right, almost 90% of our animals and plants come from rainforests.
That's an amazing number when you consider how small rainforests are throughout the world. And with all that recycling, with all the plants and animals, as they die and fall to the forest floor, they're recycled very quickly. So the soil never gets more than a few inches thick. And TJ, you know what that means for trees when the soil's only a few inches thick?
That means shallow roots.
Their roots don't go down, their roots have to go out. And when the trees are cut down, what happens is the rain come along and wash that soil away very quickly, and almost overnight you can transform a rainforest into
a desert.
A desert. So you go from a tropical, lush environment, which there are lots of plants and animals, into one in which there are very few animals or plants can possibly live. This is a great experience for us to be here in the rainforest.
Right, I finally realized how important rainforests are to us.
Let's go explore some more.
Okay. I'm glad I know a lot more about cycles and how everything I do affects everything else. Well, it's time to cycle on out of here. If you had a great time today, tell everybody that science is fun-tastic.